So, in scientific notation, one of the most important things you can do, one of the most important things you'll be asked to do, especially on the test, hint, 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 is comparing how big one number is compared to another. So, for example, it might say how many times larger, or how much larger, how many times larger is this number compared to this number, right? So before I actually start talking about this, I want you to do a little bit of thinking. How much larger do you think this number is than that one? Because remember, this represents a number, right? Scientific notation. So numbers are pretty easily comparable, right? 100 is huge compared to the number 1, but 100 is small compared to 1,000. So, looking at these, how do you feel? How close in size do you think they are? Are they basically the same? Is the first one maybe just a little bit bigger? Is it clearly larger, but maybe not a lot larger? Or is it a lot larger? So what I want you to do is I actually want you to spend just a minute thinking about this. So go ahead and pause the video and really put some thought into it. And once you're pretty sure you have a good answer in your head, you can unpause. So go ahead and pause now. Okay, so hopefully you did that, right? If you actually follow along, if you actually do the pausing, you'll learn more, okay? So keep that in mind. Before I actually talk about this and how these numbers actually compare, let me show you a much easier example. What if the numbers we were comparing were 7 and 21? Okay, so the question is, how many times larger is 7 than 21? Well, that's just really simple division. You take this one and you divide it by that one. So 21 divided by 7 equals 3. So 21 is 3 times larger than 7, right? Pretty straightforward. So 7 times 3 is 21. So 21 is 3 times larger than 7. It kind of works exactly like that just sounds. So it's just division, right? That's all it is. Very simple division. If we were talking about these numbers, you might think that 21 is just a little bit bigger. You might think that it's larger, but not a lot larger. You probably wouldn't say a lot, right? So that's all caps, a lot larger. On the other hand, what if it was 20,000 and 50? Now, instantly, I'm sure you all know 20,000 is big. 50 is not all that big, right? So this should be way bigger than that. And we can actually do this mathematically again through the wonder of division. So if you take 20,000 and you divide that by 50, you do in fact get 400. Thus, 20,000 is 400 times larger than 50. And maybe you're thinking, that's a lot larger. And you know what? I would agree with you. I would say that 400 times bigger is pretty significant. Now, if you've yet to watch my video about multiplication and division, you might want to watch that because I might just kind of gloss over some of the finer details of division, because that's what we're doing with this. Comparing it has a lot to do with division, especially if we're seeing how many times larger something is than something else. So let's look at these again, right? Just like we did with 21 and 7, just like we did with 20,000 and 50, we need to divide. So these need to be divided, and I can just draw like that, and boom, now we're dividing. One thing you may not have ever thought about is the fact that division that looks like this, like 8 divided by 4 is 2, is the same thing as 8 divided by 4, which is 2, and it can also be written like this. 8 divided by 4 is 2. Fractions are just division, right? So 1/2 is just 1 divided by 2. And if we actually do that, 1 divided by 2 is 0.5. So you probably knew that 1/2 was 0.5. So fractions are division, division is fractions. So don't let that confuse you. It is a fraction, but that's only because fractions are division. So in order to divide, what we can do is break this apart, right? Like an earthquake came, and we can do 8 divided by 2 times 10 to the 13 divided by 10 to the 10. Okay, so from here, we just do the division here. 8 divided by 2 is 4. We drop down that multiplication symbol. And then whatever you divide, you're subtracting the exponents because the base is the same. The base on both of these is 10. So when you divide, you just subtract. So 13 minus 10 is 3. Oh, it's not x to the 3. It's times 10 to the 3, right? Times 10 to the 3. So let me write that over here so it looks a little neater. So 4 times 10 to the 3rd power. So this number here is 4 times 10 to the 3rd times larger. But that may be really hard to conceptualize. So let me convert this into into standard notation. It's currently scientific. Let's put it into standard. So I can put down my 4. I know that my decimal is currently here, and I need it to move over 3 spots. So there's 1, there's 2, there's 3. So now it's here. Maybe put a 0, and then I just fill in the zeros for my gaps. So 1, 2, and 3. 3 gaps. So it's the number 4,000. So this number is 4,000 times bigger. Did your brain just explode? My brain just exploded a little bit. We thought 400 times was bigger, the difference between 50 and 20,000. This is even larger. Let me show you just something to kind of help you visualize. Okay, so using that, the 21, the 3, and the 7. So 3 times larger means that there's going to be 3 boxes. Each of those boxes contains the number 7, and if we add them together, we should get 21. And we do. 7 plus 7 plus 7 is 21. So this tells you how many boxes. That tells you what to put in the box. That tells you what it should equal, right? It's amazing how often math is actually just making rectangles. Let's look at another example. 63 compared to 7. Well, let me pull up a calculator. 63 divided by 7 is 9. So we should have 9 boxes, and we do, each of them with a 7. So we just draw a bunch of plus symbols. And maybe that here again equals. And if I actually grab my calculator, 7 plus 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 7 is 63. Okay, so I'm getting to a big point, so just bear with me for one more second. So again, number of boxes, what to put in each box, and when you add all of them together, that's what you get. Now let's talk about what we just did in scientific notation. This grid here has 4,000 squares. And I know it has 4,000 squares because this has length 40. So this is 40 boxes, and this is 100 boxes. So 40 times 100 is 4,000. So this is what 4,000 boxes actually looks like. This yellow portion here, that's 100. So here's 200, 300, 400, 500, 600, 700, 800, 900, 1,000, 2,000, 3,000, 4,000, right? So each one of these teensy tiny boxes represents 2 times 10 to the 10, which, by the way, is 20 billion, right? So we have hundreds, thousands, millions, billions. 20 billion is that number. So what do? Well, we take 20 billion plus 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 20 billion, and I keep going for every single one of these dots. So every single one of these little dots, this little dot right here, 20 billion. That one, this one, these are all worth 20 billion, and there's 4,000 of them. When all of these are added together, boom, that is 8 times 10 to the 13, which, let me actually show you what that number looks like. So that is 8 with 13 zeros. Counting zeros won't work unless there's not a decimal in a number. So if it was 8.9, counting zeros won't work, but because it's only the number 8, we can just do zeros. So there's 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And let's put some commas in there. Whew. So, as you can see, let me move this over so they're a little easier for you to compare. This number is huge. Okay, if we can just cancel all this off, this is the difference between 20 and 80,000. $20, $80,000, right? The cost of an Applebee's $20 for 2 meal versus like a pretty decent like recreational vehicle. So these are hugely different numbers. Imagine paying $80,000 cash using $20 bills. That's what this is. You would have to lay down 4,000 bills, which is crazy. So here's the big point. Let me go way back. Let me go way back to this slide here. The correct answer, in my opinion, and obviously this is pretty arbitrary, is a lot larger. I don't know if the word a lot really does it justice. These exponents make a huge difference, okay? Please don't think that, hey, this is only plus 3. Plus 3 is not a big deal. It's a lot more than that, okay? Now these numbers are really important too, right? This is where we got the 4 and the 4,000 as opposed to just being 1,000. So these numbers are really important, but these numbers are really important, okay? So try to keep that in mind. And let me just encourage you to reflect on this picture one more time, because each one of these is worth 20 billion as an individual. Crazy. You have a good day. I sincerely appreciate you watching. Take it easy.